Case study, Unmasking Cyber Threats, Enhancing Anomaly Detection with Unsupervised Learning at Cybersecure Inc. The potential of unsupervised learning in transforming anomaly detection within cybersecurity cannot be overstated. Imagine a corporate office where every click and keystroke contribute to a massive, intricate web of data. For Cybersecure Inc., a leading cybersecurity firm, vigilance against cyber threats is paramount. Dr. Emily Chen, the chief data scientist, has been tasked with enhancing the company's cybersecurity defenses using machine learning techniques. Emily's team often contends with the challenge of detecting anomalies in a sea of data. Traditional rule-based systems have proven inadequate given the dynamic and evolving threat landscape. Emily convenes a team meeting to discuss the implementation of unsupervised learning for anomaly detection. Dr. Chen presents a thought-provoking question to the team. How can we identify threats that we do not have signatures for using unsupervised learning? The first concept Emily discusses is clustering, a fundamental technique in unsupervised learning. She explains that clustering algorithms like k-means, hierarchical clustering, and dbScan group similar data points based on specific criteria. Anomalies are detected when data points deviate significantly from these clusters. In the context of network security, establishing a baseline of normal network traffic using clustering can be highly effective. For instance, what if an unusual spike in traffic from a single IP address were detected? This could signify a potential threat. Emily's colleague, Mark, raises a critical point. If clustering is so effective, why do we still face challenges in real-time anomaly detection? Emily clarifies that while clustering is powerful, it can be limited by the curse of dimensionality, where high-dimensional data makes clustering less effective. However, techniques like principal component analysis can help reduce dimensionality, making the data easier to analyze. PCA transforms data into a new coordinate system, highlighting the principal components where the most variation occurs. Anomalies can then be detected by identifying data points that lie far from these principal components. Emily then delves into the topic of autoencoders, a type of neural network used in unsupervised learning. Autoencoders work by compressing data into a lower dimensional representation and then reconstructing it back to its original form, minimizing reconstruction error for normal data. Anomalous data, not seen during training, results in higher reconstruction errors. Dr. Chen poses another question to her team. How can we leverage autoencoders to detect anomalies in user behavior logs effectively? Taking the discussion further, Emily introduces a case where clustering techniques could be applied to detect insider threats. Insiders who have authorized access can be challenging to detect using traditional methods. Unsupervised learning can be applied to user activity logs to establish patterns of normal behavior. Any deviation from these patterns, such as accessing unusual files or logging in at odd hours, can be flagged for investigation. Mark is intrigued and asks, how do we ensure that these flagged anomalies are not just false positives? Emily responds that distinguishing between true positives and false positives requires additional investigation and domain expertise, emphasizing the importance of a robust investigation process post-detection. Dr. Chen brings the discussion to zero-day attacks, highlighting how unsupervised learning can be pivotal. Zero-day attacks exploit unknown vulnerabilities, making traditional signature-based methods ineffective. Unsupervised learning can detect these novel attacks by identifying unusual patterns in system behavior. For example, an unexpected spike in CPU usage or an unusual sequence of system calls might indicate a zero-day attack. Emily challenges her team to think about the limitations they might face. What are the potential drawbacks of relying solely on unsupervised learning for detecting zero-day attacks? Emily also emphasizes the role of unsupervised learning in network intrusion detection systems. NIDS monitor network traffic for suspicious activities and potential threats. By employing clustering algorithms, NIDS can differentiate between normal and abnormal traffic patterns, such as an unexpected increase in traffic from a specific port or unconventional communication patterns between devices. The team discusses the effectiveness and limitations of clustering in NIDS. Emily asks, how can we continuously update our models to adapt to evolving threats? To support her arguments, Emily references a study by Chandola, Banerjee, and Kumar, which demonstrates the high detection rates and low false positives achieved by unsupervised learning algorithms in network security. Additionally, she refers to a report by the Ponemon Institute that highlights how advanced anomaly detection techniques, such as unsupervised learning, can significantly reduce data breach costs and breach life cycles. However, Emily does not shy away from discussing the challenges associated with unsupervised learning. She points out the issue of high dimensionality, where the distance between data points becomes less meaningful, making clustering less effective. PCA can mitigate this issue, but may lead to the loss of important information. Another challenge is the interpretation of anomalies. Not all detected anomalies indicate malicious activity. Some may be benign or due to system errors. This necessitates further investigation and domain expertise. The meeting concludes with a discussion on integrating unsupervised learning with other machine learning approaches. Semi-supervised learning, for example, leverages a small amount of labeled data to enhance the accuracy of unsupervised models. Ensemble methods that combine multiple models can also provide more robust and reliable anomaly detection. Emily asks her team to consider, how can we best integrate semi-supervised learning into our existing models to enhance our detection capabilities? In summary, the team at Cybersecure Inc. recognizes the potential of unsupervised learning in anomaly detection. They understand that while techniques like clustering, PCA, and autoencoders offer powerful tools, there are challenges to overcome. Continuous learning and adaptation of models, distinguishing true positives from false positives, and integrating semi-supervised methods are all crucial to enhancing cybersecurity defenses. The case study inspires the team to think critically and innovatively about how to leverage unsupervised learning to safeguard their digital assets and infrastructure.